these sections, we're going to look at division of algebraic expressions. The first example, we're going to look at it. So we're going to have two types of different divisions. The first type is when you have one terms on denominator. So one term is divided. So you're going to divide with one term. If you're dividing with one terms, then you should be able to use this method. In order to use this method, you need to remember one of the rules of exponentials. So we went over 4 rules from the previous sections, multiplication of algebraic expressions. On division of algebraic expressions, you need to remember if we have a to the nth exponents over a to the m's exponents, this is going to be equals to a to the n's minus m's exponents. So whichever it's bringing up, so whichever is changing the location will be subtract. So you don't forget about that rule, right? With that in mind, let's see if we can do the first. So we can tell we have, let me just write it again. We have 3xy over ax. So if we're looking at this separately, we see the like terms on the numerator and denominator. We have x over x. So if we just wanted to look at x over x, they cancel out each other, right? When you have, this is going to be equals to 1, right? If you have a same value on the numerator versus denominator, they cancel out each other. So that will give you 1. And what's left over? You're going to have 3y on the numerator and a on denominator. What about next one? The same reason, 10 over 10, right? 10 over 10 will cancel out. And a over a will cancel out. So this gives you b over 1, which is just going to be b. The next one, same thing, because you have x, 1x on the top, 1x on the bottom. This is going to be 1, so they cancel out each other. And because now the variable left over is on denominator, you do have to keep as the fraction forms. So it will be 1 over a. The next problem, it's getting a little bit longer and longer each time, but the basic information will be the same. So when we're comparing negative 20 with negative 4, 4 goes into 25 times. And negative cancel out. So look like from negative 20 over 4, I will have 5 on the numerator remaining. I have 2x on denominator, 3x on the numerator. So if I write that on the side, I have 3x and 2x. So this 2 and 2 cancels out. And I have 1x remaining on the numerator. Another way to say it is x cubed minus 2, right? Which is going to be x to the first exponent on the numerator. So cancel out, give you only 1x. Y, same thing, 3 minus 1, right? If you bring y to the numerator, it will be 3 minus 1. I'm looking at this. So I will get square remaining on the numerator. And the next one is same base of z. My denominator is bigger, so I will bring down to denominator this time. So that will be 5 minus 3. Gives you square. And don't forget I moved to denominator. So we'll be on denominator z squared. The next example, we have negative 18x cubed y divided by negative 12x y to the fourth. This is division problem, but also at the same time, we can rewrite this in a fraction form. And once we do that, we know that we can cancel out negative, negative. And 18 over 12, we know that 6 goes in 18 3 times. 6 goes into 12 2 times. So I will have 3 remains on the numerator and 2 remains on denominator. Let's look at x, right? So I will have this x. So numerator is larger, so I will bring it to the numerator. So it will be 3 minus 1 gives you square. So on the numerator, it will be x squared. If we're looking at y, look like denominator exponent is larger, so I'm going to bring down to denominator. It means it will be 4 minus 1, which is going to be cube, right? Don't forget that's going to be on denominator. And since we cannot reduce any further, that must be it for that problem. What about if you have more than one terms on the numerator? What does that mean and how do we do it? Well, this is going to be the same thing as what we've been doing. It's just that 2 different fractions. So this is going to be identical problem as if you have x cubed over x plus x squared over x. So make sure you use denominator twice if you have 2 terms on the numerator. So then 3 minus 1 on the first fraction, I get 2 on the numerator. And 1 on the numerator, right? And that's all I have for that problem. What about next one? The next one, you need to be careful with the signs. So this one, you have x cubed over negative x. So I'm going to pull that out in front, the negative sign. And then you have plus x squared over negative x. So that will be just 1 negative. So it will be negative. Negative 1 over negative x, that's 2 negatives, so it will be positive 1 over x. So it's a good idea that you can combine the sign first when you're separating out so that you don't get confused later on. And then let's reduce. So you have 3x on the top and 1x on the bottom. That cancel out 1 from the numerator, so you have negative x squared remains. Same reason, you get 1x cancel out, you have only x remains. The third fractions, you don't have the like term to get rid of, so it will stay as 1 over x. Next example we're going to look at in the division of algebraic expression is when you have 2 terms. So when I say 2 terms, you're dividing with more than 1 terms. Before all this other example, we were looking at it on example 1. You can see your denominator is, you're dividing with 1 term, right? 1 term. Even this one, you're dividing with 1 term, right? Dividing with 1 term. When you have dividing with 2 terms or more than 1 term, you cannot use this method. You're going to use long division method. what's the long division? So let me show you what's the long division with the numbers. You do know how to use the long division with the number. For example, let's say we have 135 divided by 5. We're going to do the long division of this, where I need to find 5 fitting into 13, because 5 do not fit into 1. So we're going to look at 5 going into 2 digits, 13. So 5 goes into 13 twice. That's going to be 5 times 2, which is 10. And then we subtract these two numbers. So then you get 13 minus 10, which you get 3. And 3 is too small and had to be smaller than 5. It means you need to bring down the next digits, 5. And we're going to find the numbers that 5 goes into 35. That will be 7, right? And when we subtract those two, it gives you 0. So this is the long divisions. So this is what we're going to use, this method, right? For dividing when you're dividing with more than one terms. So let's look at that. So the first one, we have 2x squared plus 5x minus 3. And dividing that by 2x minus 1. So if I'm going to write this down into long divisions, 2x squared plus 5x minus 3, dividing this with 2x minus 1. And there's 2 rules that you need to remember when you're doing long divisions. The first one is have to be descending order. So larger exponents to the smaller exponents, right? Descending order. And second is if you have any missing terms, then you're going to replace by placeholder. This problem, we do not have missing terms. Why is that not missing term? It's because this polynomial start with quadratic, right? Square and first power. So second power, first power, and no power, right? So there is no missing terms when it starts from square here. Same thing here. First exponent and no exponents, right? So there is no missing term between. If you have something like 3x cubed plus 1, then you have missing term between. What's missing? X squared is missing and x to the first exponent is missing between those two numbers. In that case, we're going to use the placeholder called 0 times x squared and 0 times x to the first. But so far, we don't have that missing term. So this is how you're going to rewrite as the long divisions. And then we're going to figure out what you're going to multiply to make this 2x. We're going to focusing on just first numbers. So 2x to become 2x squared. What do you need to multiply 2x to become 2x squared? That will be x. So you're going to multiply x. And I'm going to write down the same line as the x that you have right here on top of it, right? So x times, once you decide what to multiply, you multiply x times 2x minus 1. So then you get 2x squared minus 1x, right? Then you're going to subtract those two lines. When you subtract 2x squared minus 2x squared, that 2 cancel out. 5x minus negative 1x. Don't forget you're subtracting negative numbers, so same as adding. So you're going to end up getting 6x. And then you wanted to bring down the next number because what you're dividing with, you have 2 terms, so you need 2 terms. Now, you're repeating this procedure again. So you're going to think about what you're going to multiply 2x to become 6x, right? Don't worry about -1 yet, right? 2x to become 6x. 3, right? Positive 3, in fact. So you're going to multiply by +3. Once you decide what to multiply, now you're multiplying that number into 2x minus 1. So then you get 6x minus 3. And again, you're subtracting. Right? Let's see. Make sure you're subtracting. When you subtract 6x from 6x, they cancel out. -3 minus, -3 subtract -3 is going to be -3 plus 3, which is going to be 0. So I wanted to show you here, -3 minus -3 is same as -3 plus 3, which is 0, right? The other one we had was 5x minus -1x, same as 5x plus 1x, which is 6x, right? So this problem, your solution is going to be x plus 3. And if you wanted to check these problems, you should be able to multiply these two to get that numbers, right? If you multiply x plus 3 times 2x minus 1, you should be getting this back. That's how you can take your problem if you want to. We're going to try one more times using the long divisions. When we're rewriting into long divisions, make sure you're going to write it in the descending order. And if you have any missing term, use 0 as the placeholder. This problem, we do not have any missing terms. We start with cube, 3, 2, 1, and 0, right? And we start with 1 and 0. So there is no missing exponents between. So no missing terms. So write as it is. And we start by, what do I need to multiply x to become x cubed? That's going to be 2 more x. So it will be x squared. And that x squared, you're going to multiply to x plus 2. You get x cubed plus 2x squared. Now you're subtracting. When you subtract, first term will cancel out. 3 minus 2, you get x squared, 1x squared. Bring down the next term, -4x. Now we're going to think again, what do you need to multiply x to become x squared? So that's going to be x, positive x. And that x, you're going to multiply into x plus 2. Then you get x squared plus 2x. And let's subtract that again. That cancel out. -2 minus 2. You get -6x. And bring down the last number, which is -12. Let's repeat that procedure again. What do you need to multiply x to become -6x? That's going to be -6. Multiply -6 into x plus 2. You get -6x minus 12. And when you subtract those two, look like it cancels out. and that cancel out, give you 0. So your solution of that problem is going to be x squared plus x minus 6, right? Your long division will be the same thing over and over as example A and B. Only thing different is this time, if you have a missing term, use the 0 for the placeholder, right? So let's use the long division again. I will start writing by 4x cubed because you go by descending order, right? And then I have a square, which is 6y squared. Do I have first? No, you do not have first, right? You have first missing. So that is something that you're going to write it as plus 0y to the first. And then you can do plus 1. Dividing this with 2y minus 1. Once you set your problem into long divisions, then you wanted to look at what you need to multiply into the first value to make 4y cubed, right? Because you wanted to start by getting rid of 1 at a time. So what you need to multiply by 2y to make it 4y cubed. 2 times 2 is 4. You have 1y, so you need 2 more y. So you're going to multiply by 2y squared. And you're going to multiply that into 2y squared into 2y minus 1. Then you get 4y cubed minus 2y squared. And then you're subtracting, right? When you subtract, these 2 cancel out. Always first term cancel out. That's how you decide what to multiply, right? And this is going to be 6 minus negative 2, which is same as 8. That will be 8y squared. Bring down the next digits, which will be 0y. And now, repeating that procedure, what do you need to multiply 2y to become 8y squared? That will be positive 4y. And when you multiply 4y into 2y minus 1, you get 8y squared minus 4y. And let's subtract that. When you subtract that, this 2 cancels out. You get positive 4y because 0 minus negative 4, right? Bring down the next digit will be plus 1. So 2y, what do you need to multiply to become 4y? That will be positive 2. So multiply positive 2 into 2y minus 1. You get 4y minus 2. And when we subtract that, those 2 cancel out. And you get 1, subtract negative 2. That will be 1 plus 2. That's 3. So your remainder will be 3. So how are we going to write your solution when you have remainder? Your solution will be 2y squared plus 4y plus 2 and add your remainder. But your remainder have to be fraction form because that remainder didn't get to divide by 2y minus 1 because it was smaller. So that's how you write your solution with the remainder.